Okay guys, today I want to go over the rules for balancing a chemical equation. It's going to be a little bit difficult for me to explain this without showing it to you on a whiteboard. So one of the assignments for this week will be just balancing a whole bunch of different chemical equations. I highly suggest you watch my video and you just basically take it trial by error. So to write these, the first step is you need to write, if they don't give it to you already, which in the assignment for this week I'm going to, you need to write the skeleton equation, which is the equation that shows the correct formulas for the reactants and the products, and basically what's reacting and what's being formed. Now, again, the examples I give you this week, I'm going to give you the skeleton equation, but you should also be able to write them at this point. Okay, after you write the skeleton equation, you need to count how many of each element, how many atoms of each element are on both sides of the equation. We'll do an example in a second. Okay, then if the number of elements are different on one side and the other side, you have to balance them by adding coefficients. Now, sometimes the equation will be written already balanced and you don't have to add anything, and it's already done. Those are uncommon, but they do happen. But if you need to balance it, you have to add coefficients in front of the different reactants and or products. Now again, this sometimes takes trial and error. Some of them are a little harder than others. Sometimes you have to play around with the numbers. I highly suggest you guys use a pencil when you do these because you may be erasing or scratching things out kind of frequently. Okay, I also highly suggest you always save hydrogen and oxygen until last. They are generally the most difficult ones, and if you try balancing them first, it often causes a lot of issues. So I highly suggest you save those ones for last. So focus on the other elements first, and then when you have just hydrogen or oxygen left, do them at the end. Okay, and then finally, after you think you have it balanced, I always suggest you double check just to make sure it is balanced. Okay, so let's do an example. So it says hydrogen gas and oxygen gas react to form liquid water. So step one is we write our skeleton equation. So H2, which is hydrogen gas, I put the little symbol G there, plus means it reacts with O2, which is oxygen gas, and I put the little G there because it's a gas, and then the arrow means to form, and then H2O, liquid water, and I put the little L there to indicate it's a liquid. Okay, now step two, I'm going to count the number of each element on both sides. So on the reactant sides, I have 2 hydrogens and 2 oxygens. On the product side, you have 2 hydrogens, 1 oxygen. Now, when you do these problems, you don't have to write these things down. Step 2, I mean, you could if you really want to, but you can just think about it in your head. If you really want to write things down, that's totally okay, but I suggest you get in the habit of just kind of looking at them and just kind of seeing which ones are different. So if you notice, I have 2 oxygens on the left and only 1 on the right. You can't just destroy an oxygen atom. So I have to somehow balance this equation to fix this problem. So to fix this problem, I'm just going to give you the answer now, then I'm going to explain it. If you notice, I added a 2 in front of the water and a 2 in front of the hydrogen. Let me walk you through why I did that. So I noticed there's 2 oxygens on the left and only 1 on the right. So to fix that, I need to add another oxygen on the right so that I have 2 on the right and on the left. So I put a 2 in front of the water. Now, remember, that 2 distributes to all the atoms in that compound. So I fixed the number of oxygens. I now have 2 on the left and 2 on the right. However, now I have 4 hydrogens on the right and only 2 on the left. So to make it so I have 4 on the left as well, I had to add a 2 in front of the hydrogen. So now if you look, I have 4 hydrogens. So this is my double check step. I have 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, 2 on the right. Okay, so everything is balanced. I'm good. Okay, example 2. Solid sodium reacts with gaseous oxygen to produce solid sodium oxide. Okay, so solid sodium is Na with a little S next to it, reacts with oxygen gas, O2 with a little G next to it, and it produces sodium oxide. Now, at this point, I'm assuming you guys can write these formulas. You guys remember, you have to take out your ion sheet. Sodium has a positive 1 charge. Oxide has a negative 2 charge. So to balance it, I had to cross that 2 down there. So I get Na2O, and it's a solid, so I put the S there. Okay, so step 2, I count my reactants and products. I have 1 sodium and 2 oxygens on the left. And on the right, I have 2 sodiums, 1 oxygen. So notice both of them are not balanced, both things. Okay, so Some of them are easy to balance. So the first thing I would do here, you see I have two oxygens on the left, only one on the right. The only way to fix that is by adding a 2 in front of the sodium oxide. So I'd put a 2 right there, but when I do that, I would notice now I have 4 sodiums on the right and only 1 on the left. So I could fix that by adding a 4 in front of the sodium. Okay, so then I skipped step 4. You should always double check though. Okay, example 3, solid aluminum reacts with gaseous oxygen to produce solid aluminum oxide. Okay, so I write my skeleton equation, Al, little s next to it, reacts with O2 as a gas to form Al2O3. Again, you had to pull out your ion sheet to figure out this formula. Aluminum has a positive 3 charge, oxide has negative 2 charge, cross them down. Okay, so I notice here, this one's a little bit more difficult because I have 2 oxygens on the left and 3 on the right, and the aluminums are also wrong. Now, I personally, I know I told you to save oxygen for last. You could. It always works no matter which one you save for last or do first, but it takes more playing around. This one, I would actually do the oxygen first. If you notice, I have 2 on the left and 3 on the right. The only way to get these two the same is I have to find the lowest common denominator between 2 and 3, which becomes 6. Okay, so I need to get 6 oxygens on both sides. So I would do that by adding a 2 in front of the aluminum oxide, so 2 times 3 is 6, and over here on the left I would put a 3 in front of the oxygen, 3 times 2 is 6. Now, this would change the number of aluminums. So because I put a 2 over here, 2 times 2, I'd have 4 aluminums on the right, I'd have to add a 4 on the left. Okay, so I just went through the whole thing. I would count up my number of reactants first, and then I would balance it in the way that I just said. I would start with the oxygens, make it 6 because it's the lowest common denominator, and then do the aluminums last. And then I would double check to make sure it's right. Okay, one last example. Iron 3 chloride reacts with calcium hydroxide to produce iron 3 hydroxide and calcium chloride. Okay, again, you would have to pull out your ion sheet. Hopefully you guys remember how to write your chemical formulas. So iron 3 chloride is FeCl3. Calcium hydroxide would be Ca parentheses OH2. And then iron 3 hydroxide would be FeOH3. And calcium chloride would be CaCl2. Now, this one's even harder because we have the parentheses. Okay, so first I count my reactants and my products. You can see just right off the bat I have the same number of irons on both sides, which is 1. My chlorines change from 3 on the left to 2 on the right. My calciums stay the same. My oxygens change from 2 on the left to 3 on the right. And my hydrogens change from 2 on the left to 3 on the right. Okay, so just looking at this, again, I highly suggest you generally save oxygen, hydrogen last. So the first thing I would see when I see this problem, I would see I have 3 and 2 with the chlorines. Just like I did in the last problem, I have to find the lowest common denominator between them, which is 6. Okay, so to start this problem, I would put a 2 in front of the FeCl3 to get 6 chlorines, and then in front of the calcium chloride, put a 3 to get 6 chlorines. Okay, that only fixes the chlorines. Okay, next, now that I have 2 irons over here, I only have 1 on the right, so I would put a 2 in front of the FeOH3 on the right. Okay, then, if you remember, I put a 3 in front of the calcium chloride on the right. That means I need to put a 3 in front of the calcium hydroxide on the left. Now, when you do that, so if you look below in step 3, I just put in those numbers that I was just mentioning. Once you do that, the oxygens and the hydrogens, if you count them out, they already take care of themselves. If you look on the left, I have 6 oxygens, and on the right, I have 6 oxygens. On the left, I have 6 hydrogens, and on the right, I have 6 hydrogens. The oxygens and hydrogens kind of generally balance themselves out if you handle the other elements. Now, don't just assume they're going to balance each other out. You should always double check. Okay, there's some more practice problems I'd like you guys to just try. The answers are right here. I'd like you to try them first on your own before you check out the answers, just to make sure you guys are capable of balancing the equations. Okay, then at this point in your notes, there's like 9 review questions. They're all just balance some chemical equations. So I know it sounds like 9's a lot, but it's just balance the chemical equations. If you guys have any questions, let me know. Do not turn in your notes yet this week. I'm not going to collect them until we are done with the entire note packet.